Okay, let's get rolling here. All right, so we got three different problems here, which we're going to get through. And if we just take a brief look at all three of them together, you can see this one, right? If we just identify the parts, right? On this one, C is our hypotenuse, right? Because that's the one that's across from and does not touch the right angle. And the right angle is always marked with like a box. And then 6 and 8 are the legs, right? So leg and leg, right? I shouldn't write legs, I should write leg because it's only one. B, got a leg here. And then this is A, the missing piece is a leg. And then 9 is our hypotenuse, all right? So there is that. And then this one, it's across from there. 25 is the hypotenuse. B is a leg. And 24 is a leg. And you'll find in most of these, when they do use A, B, and C for like the different parts of the triangle in the theorem, it doesn't matter which one you call A or B. I mean, use it how they label it, but I mean, 8 very well could have been A, and this could be B. Or this could be A, and 24 could be B instead. So it just doesn't matter, right? The only thing that does matter is C is always the hypotenuse, right? Always. So that is the most important part. I'm going to erase that and move this up a little bit so we can see it. Yeah, as long as you keep that straight, you're good. All right, so let's get going. So we're going to use this A squared. I'll write this down. We got A squared plus B squared equals C squared. All right, so in this one, we can call either, well, let's call this A and let's call this B. All right, so we got 6 squared, right? 6 goes in for A, plus 8 will be our B. B squared equals C, which is, in this case, unknown. So it's C squared, right? So you got 6 squared plus 8 squared equals C squared. So we are going to square these both. So 6 squared is 6 times 6, 36, plus 8 times 8 is 64, equals C squared. We can drop the parentheses. 36 plus 64 is 100, equals C squared. And then the last step is to always recognize that we're going to take the square root of these, because to undo a square, you use a square root. So we're going to take the square root of this, and we're going to take a square root of this. So you take the square root of both sides. And you do this to get this to be C. And the other thing to remember is in the past, when we've taken square roots of things, we've usually done like a positive and a negative root. For these, because of the application, and we're talking about lengths, right, we're always just going to use the positive root. So for this one, I'm just going to have one answer. So the square root of 100, what number do you multiply by itself to get 100 is 10, right? And so your answer is 10. All right, so that is letter A, so the first one. All right, now for letter B, here's our 2 legs and here's our hypotenuse. So when we set it up, we can go A squared plus, and then B is given, is 8. 8 squared equals 9 squared. All right, sorry, that equal looks, I don't know what it looks like, but it doesn't look like an equal sign. Equals 9 squared. And so now the next step is just to square your numbers. So 8 squared is 64 and 9 squared is 81. So we are going to, what you do next is you always solve for whatever variable you're trying to find, and you have to isolate it first. So this 64 has got to go, right? So we're going to move the 64 over to the other side. You're going to get 17, and you get A squared over here. And then the last step is to take the square root of both sides, and you will find with many of these that these do not give you nice, clean answers, all right? And so what you want to do is just leave it as a radical, because it is it's exact as a radical. We can look it up, and then later, if we're doing some kind of a practice problem, then we can write it as a decimal. But rather than doing this and putting it in a calculator and coming out as 4 point something with some crazy decimal, we are just going to leave it like this, because it can't be simplified, and it's good. All right. And the numbers to look for when we look for simplifying these is if you can divide this if you can multiply it into two factors where one of them is a square number, and these are the square numbers we're always looking for, right? You got 2 squared, 3 squared, 4 squared, 5 squared, 6 squared is 36, 7 squared is 49, 8 squared is 64, and 9 squared is 81 and 100, right? Most of the time you're not going to get too much bigger, but you never know. All right, so for this one, it's, again, we're going to do a squared plus b squared equals c squared. Well, b is the one we're looking for, right? So we'll put b squared there, and a is 24. So we're going to go 24 squared plus b squared equals 25 squared. All right, well, 25 squared is 625, and 24 squared, what is on earth is going on? 24 squared is, I can't remember, so pulling up the calculator, is 576. All right, so you got 576 plus b squared. All right, so you subtract 576 from both sides because, again, you want to get this by itself. All right, and so 5 minus 6 is 9, or 15 minus 6, right? You borrow one from here. Right, you got 15, and then we're going to need to borrow one from here to make this 11. 11 minus 7 is 4, and then 5 minus 5 is 0. So we get 49 is equal to b squared. This is one of the Pythagorean triples. So this is something that works out that is going to give us a nice clean answer, because when we take the square root of both sides, keeping in mind we only want the positive one, you get a nice clean answer. You get 7, because that's 7 times 7 is 49. So this is, again, Pythagorean triples, right? There's like this was 1, 6, 8, 10, right? This obviously was not 1 because we got something like this, and then here's another one. So if you work with these enough, you'll start to remember some of these. And 3, 4, 5 is a very common one. 6, 8, 10, any multiple of that is going to work. The 7, 24, 25 is a big one, and then the other one you'll see quite a bit is the 5, 12, 13 is a pretty common one. All right, so there you go. That's how these work. Always just solve for the one you want to find, and then usually wind up with the square root. And then if you can simplify it, you do, and if you can't, you leave it as a radical. Okay, which is a little different from geometry, because in geometry a lot of times they want you to write it as a decimal. So we will do that on a few occasions, but most of the time we're going to leave it as a radical, especially with the trigonometry functions we're going to use it for. So there you go. Good luck.